Space is beautiful, space is infinite, and space is absolutely lethal. But here's the thing, not all deaths in space are created equal. Some places in space are so horrifically dangerous that dying there would be, well, let's just say you'd wish for a quick end. Today, we're exploring 5 of the absolute worst places to die in space. And trust me, you'll never look at the cosmos the same way again. Let's start with number 5, the Asteroid Belt. Most people think the asteroid belt is this dense field of rocks constantly crashing into each other like some kind of cosmic demolition derby, right? Wrong. The reality? It's actually more empty space than actual asteroids. You could fly through it and probably never hit a single rock. But that's not why it's on this list. Imagine this scenario. Your spacecraft breaks down between 2 asteroids. You're stranded. Your communications are dead. It's just you and the vacuum of space. Here's what happens. First, hypothermia sets in. In the shadow of an asteroid, temperatures drop to minus 180 degrees Celsius. That's colder than Antarctica. That's colder than anywhere on Earth. Your suit's heating system is failing. You have maybe 20 minutes before you can't feel your extremities anymore, before your body starts shutting down. But that's not the worst part. The worst part? The asteroids are slowly rotating. One asteroid might complete a rotation every 4 to 6 hours. You're watching the scenery slowly change, and in the distance, you see your rescue ship, but it's on the other side. And those asteroids are in the way. You radio for help, but there's no response. You watch your oxygen counter tick down. 48 hours of oxygen left, then 24, then 6. You could try EVA spacewalking to the other side of the asteroid. But one mistake, one misstep, and you're drifting into the infinite void, completely unreachable. The asteroid belt isn't dangerous because of collision. It's dangerous because it's the perfect place to be trapped, slowly dying, watching your potential rescue just out of reach. Number 4, near a magnetar. If a neutron star is already terrifying, a city-sized object with the mass of the sun, spinning 500 times per second, then a magnetar is neutron star's absolutely unhinged cousin. A magnetar is a neutron star with a magnetic field so powerful, so devastatingly intense, that it would literally rip the iron from. Let me put this in perspective. A regular magnetic resonance imaging machine, an MRI, has a magnetic field of about 1.5 Tesla. A magnetar has a magnetic field of 1 to 100 quadrillion Tesla. That's not an exaggeration. That's the actual number. So what happens when you get near one? From about 1,000 kilometers away, your spacecraft's electronics start failing. Not because they're damaged, because the magnetic field is literally rearranging electrons in every circuit board, every computer, every navigational system. You're now flying blind, at speeds you can't control, toward an object you can't see clearly. As you get closer, maybe 500 kilometers, the magnetic field starts affecting your body at a molecular level. Not painful yet, but you feel wrong, disoriented. Like your entire sense of up and down is being scrambled. 250 kilometers away, your suit's mechanisms start failing. The magnetic field is pulling on any ferrous metals in your suit. Your joints stiffen. Your armor cracks slightly from the internal forces. 100 kilometers away. This is where most sources say you'd be killed instantly. But here's what actually happens, it's far worse. The magnetic field, stronger than anything imaginable, reaches into your cells. It doesn't kill you immediately. Instead, it causes spaghettification on a molecular level. The atoms in your feet are being pulled with more force than the atoms in your head. You don't just die, you literally come apart, in agony, torn apart by invisible forces you can't see or defend against. And the worst part? If you somehow survived the initial exposure, the radiation from the magnetar's constant gamma-ray bursts would cook you from the inside out. Number 3, inside a gas giant. Jupiter, Saturn, Neptune, Uranus. These massive planets are beautiful from a distance, but up close, they're absolute hell. Let's say, for some reason, your spacecraft descends into the atmosphere of a gas giant. Maybe your engines failed, maybe you were curious. Either way, you're going down. Here's how you die. Phase 1, radiation, first 10 minutes. Gas giants have intense radiation belts that would make the Van Allen belts around Earth look like a gentle suntan. Your shielding can only take so much. After about 10 minutes of exposure, your radiation sickness has begun. You feel it first as heat, a burning sensation across your entire body, even inside your suit. Phase 2, pressure, 10 minutes to 1 hour. As you descend deeper, the atmospheric pressure increases exponentially. At the level of Earth's atmosphere, we have 1 bar of pressure. At the upper clouds of Jupiter, you're looking at 1 to 2 bars. Still livable. But go deeper, and the pressure becomes crushing. 100 bars. That's like being 1,000 meters deep in Earth's ocean. your spacecraft creaks, your suit's integrity becomes questionable. Phase 3, winds, throughout descent. Here's where it gets truly horrific. The winds in the upper atmosphere of Jupiter reach 600 kilometers per hour. That's 60 times stronger than hurricane-force winds. Your spacecraft isn't being pulled down gradually. It's being torn apart by winds so violent that your hull literally comes apart at the seam. You're now exposed to radiation, crushing pressure, and winds that are ripping your body apart. And you're still alive. But not for long. The final phase. If, and this is a big if, you somehow survive being ripped to shreds by wind and crushed by pressure, there's one final indignity. The deeper you go, the hotter it gets. Some models suggest temperatures 20,000 kilometers below the surface reach 5,000 Kelvin. That's hotter than the surface of the sun. You don't just die in a gas giant. You're destroyed by radiation, ripped to shreds by wind, crushed by pressure, and finally, burned to ash. All at the same time. Number 2. And this one is purely theoretical but absolutely terrifying. Inside a black hole. Black holes are objects so dense, so massively powerful, that they literally tear apart the fabric of spacetime itself. But here's the thing that makes this worse than everything else we've talked about. You might not even know you're dead. Let's start with the event horizon, the point of no return. Cross this line, and you can never leave. But the crazy part? From your perspective, as you cross the event horizon, you feel nothing. Everything feels normal. You're floating. Your suit's reading are fine. To you, in your reference frame, it's like any other moment in space. But to someone watching you from a distance, they see something very different. Time dilation, the horror. They watch you approach the event horizon. From their perspective, time itself slows down around you. Gravity pulling on your head. This effect is called spaghettification, and it's as terrible as it sounds. You're being stretched, pulled apart vertically while being compressed horizontally. Every cell in your body is being ripped away from the cells next to it. This would happen at different rates depending on the black hole size. For a stellar mass black hole, 20 times the mass of our sun, you'd be spaghettified well before crossing the event horizon. But for a supermassive black hole, like the one at the center of our galaxy, with 4 million times the sun's mass, you might cross the event horizon completely unaware, and only experience spaghettification much deeper inside, because it means you'll be conscious through the entire process, watching yourself being torn apart. Aware that you're falling toward a singularity, a point where the laws of physics literally break down. And then, finally, you reach the singularity. What happens there? We don't know. Physics as we understand it completely breaks down. Some physicists theorize you'd be crushed to infinite density in an infinitesimal moment. Others think you might experience infinite time in finite spacetime. But we do know, you're definitely dead. And the universe will never know what happened to you. Your information is literally lost to reality. And finally, number 1, the surface of the sun. Now, you might be thinking, wait, why is the sun's surface worse than a black hole? Great question. Because with everything else on this list, at least there's something fascinating happening. Some interesting physics, some mystery. But the sun? The sun is pure, unrelenting, unavoidable, senseless death. The surface temperature of the sun is approximately 5,500 degrees Celsius. That's hot enough that your entire body would vaporize instantly. Not burn. Not char, vaporize. We're talking about the atoms that make up your body literally separating from each other and turning into superheated plasma. But before your atoms even have a chance to vaporize, you're being hit with radiation so intense that it penetrates every cell in your body. We're talking about gamma rays, X-rays, and solar radiation that would irradiate your entire being millions of times over in less than a second. Your DNA doesn't just break. It disintegrates. And here's the part that's somehow worse than all of it. The sound of the sun is in a constant state of violent plasma discharge. Massive explosions and solar flares happening every single moment. The roar of the sun's surface would be so loud, so physically intense, that it would liquefy your brain inside your skull. All of this happens simultaneously, in literally less than a millisecond. So why is this number 1? Because there's no mystery, there's no interesting physics to contemplate, there's no moment of wonder before your death. The sun isn't trying to kill you through exotic phenomena or quantum mechanics. It's just burning. Violently. Indifferently. Simply. It doesn't care about you. It's not evil. It's not conscious. It's just a massive ball of nuclear fusion, and you happen to get too close. And you'd cease to exist so quickly that your consciousness wouldn't even have time to register that it happened. So there you have it, 5 of the worst places to die in space. And honestly, they all share something in common. They're all reminders of just how fragile human life is. How dependent we are on very specific conditions to survive. How absolutely brutal and unforgiving the universe can be. We live on this planet with stable gravity, breathable air, and a protective magnetic field. And we think of ourselves as advanced, as powerful. But the moment we step outside this bubble, we're nothing. We're atoms held together temporarily by chemistry and luck. Space doesn't just kill you, it doesn't even acknowledge your death. You're simply gone. Incorporated back into the universe as dust and